Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0657, indicates a malfunction within the Powertrain Control Module, PCM, power supply circuit. This code specifically points to issues affecting the connectivity and integrity of power supply components, crucial for the PCM's operation. The PCM, located typically under the dashboard, serves as the electronic brain of the vehicle, processing data from various sensors and accordingly controlling engine functions to optimize performance. The proper functioning of the PCM is vital for emission control and fuel efficiency, making issues linked to its power supply critical. In this troubleshooting guide, we will systematically address the potential areas of failure, starting with the initial verification steps and advancing through a detailed inspection process of components relevant to this code. The Powertrain Control Module, PCM, plays a pivotal role in vehicle operation by processing inputs from various sensors and determining output conditions for engine management. The power supply circuit ensures that the PCM receives adequate voltage for proper functionality. Key components involved include the relay circuit board, which is responsible for routing power to the PCM, as well as various fuses ensuring circuit integrity and protection from overload. In the Honda Civic 2016 to 2021, the relay circuit board is typically located within the underhood fuse relay box. Additionally, the power supply line includes fuses such as A7, 15 amp, that act as protective devices against shorts, helping sustain operational reliability. When diagnosing, it is crucial to understand the implications of each component's role within this circuit, as failures can directly impact vehicle performance and safety. Several factors can cause the DTC P0657. A faulty relay circuit board might disrupt the power routing to the PCM, leading to failure. A blown fuse, specifically fuse number A7, 15A, can cut off the power supply entirely, preventing the PCM from operating as intended. Shorts or open circuits in the wiring between the relay circuit board and the components it serves can also cause disruptions. These wiring issues might stem from deterioration, accidental damage, or poor connections, amplifying the complexity of the electrical system diagnostics. Identifying these potential causes is paramount because they directly influence the troubleshooting process and the necessary repairs. The presence of DTC P0657 may manifest in several noticeable symptoms. One of the primary indicators is the engine failing to start, which may occur due to lack of power supply to the PCM. Additionally, drivers might experience intermittent electrical issues, sometimes caused by the inconsistent signals resulting from a faulty power supply circuit. This can lead to erratic performance, such as sudden power loss or malfunctioning engine components. Notably, the check engine light will illuminate on the dashboard, alerting the driver to the presence of a trouble code. Recognizing these symptoms early can be vital in deciding the appropriate course of action and minimizing further damage to other components. The first step in troubleshooting DTC P0657 involves confirming the presence of the error code. Begin by turning the vehicle's ignition to the on position without starting the engine. This allows the onboard diagnostic system to perform checks without engaging the engine. Next, clear the DTC using the Honda Diagnostic System, HDS, which resets the onboard systems and may provide clarity on any persistent issues. After clearing, start the engine and observe for new DTCs. Check if P0657 is now showing as confirmed or pending. If it appears confirmed, this indicates an active fault, and you must proceed to the next diagnostic step. If it does not appear, it may suggest an intermittent failure, which necessitates examining connections at the relay circuit board and PCM. In the second step, ensure the vehicle is in off or lock mode before proceeding. This precaution is critical for safety and to prevent electrical shorts or further damage during the handling of components. Remove the relay circuit board from its position, typically located in the underhood fuse/relay box. With the board removed, conduct a thorough test to ascertain its functionality. A properly functioning relay circuit board is essential for efficient power distribution to the PCM. If the board passes the test and is deemed operational, you will move forward in the troubleshooting process. Conversely, if it fails, replacing the relay circuit board becomes necessary to resolve the power supply issue. The third step is vital in identifying if a blown fuse is contributing to the DTC P0657. Specifically, check fuse number A7, which has a rating of 15 amps and is located within the underhood fuse relay box. This fuse protects the relay circuit board and its associated wiring. If the fuse appears intact visually or via a continuity test, it is deemed functional, allowing you to proceed with further diagnostic steps. However, if it is blown, this indicates something within the circuit may be shorting or overloaded, necessitating repairs to underlying issues while also replacing the fuse itself. Therefore, determining the fuse's condition is a critical step before proceeding to more complex diagnostics. Step 4 involves determining the exact area of failure, especially if fuse number A7 has blown. To begin, remove the blown fuse from the underhood fuse/relay box and then detach the injector relay. This setup minimizes variables by isolating circuit paths. With the components disconnected, check for continuity between the specified test points. The relay circuit board connector C18P terminal number 18 and the injector relay 4P socket terminal number 1. 7. Against body ground. Continuity tests ensure there is an uninterrupted electrical path, essential for the power supply circuit. If continuity is present, this identifies a short in the power supply wire that needs repair, along with replacing the blown fuse. If continuity is absent, you will advance to the next troubleshooting step. For step 5, use the Honda Diagnostics System HDS to jump the SCS line, enabling communication with the vehicle's ECU while isolating specific components. After waiting for over a minute, check for continuity between designated test points while disconnecting components one at a time, including the PGM FI main relay 2 and PCM connector A 50P. This method effectively isolates the malfunctioning part by breaking the circuit and confirming if continuity disappears. Should you observe that continuity ceases upon disconnecting a specific component, that part is likely the source of the issue and should be replaced. This step confirms that individual parts of the circuit are functional and assists in narrowing down specific components that might trigger DTC P0657. The sixth step focuses on scrutinizing the PGM FI main relay 2 and the associated FI main relay outline for continuity issues. Begin by disconnecting connectors, including the PGM FI main relay 2 and the PCM connector A 50P. This setup allows you to measure the continuity between specified test points in the circuit while ensuring that all variables that might cause false readings are eliminated. The aim here is to check if there is maintained continuity between terminal number 8 of the PCM connector and body ground. If continuity exists, it indicates an issue like shorting in the FI main relay outline, requiring repairs to ensure stable signal transmission from the relay to the PCM. If continuity is absent, the relay circuit board may need replacement and the associated fuse also replaced. In step 7, Return to the diagnostic process by turning the vehicle back to the off mode. Reinstall the relay circuit board securely, as proper connections are crucial for effective diagnostics and operability. Once again, utilizing the HDS, jump the SCS line and allow a minute for the system to stabilize. Next, disconnect the PCM connector A 50P, as this will facilitate the measurement of voltage across specified test points using a multimeter. By measuring voltage between connector number 5 and body ground, you can determine if battery voltage is reaching the PCM. If voltage is present, it implies the power circuit is functioning correctly so that you can proceed to the next step. If voltage is absent, further examination is required to check for power supply integrity. Continuing in the troubleshooting steps, Step 8 requires disconnecting the relay circuit board connector, C, to facilitate voltage measurements. The focus here is to measure voltage between terminal number 18 of the connector and body ground, ensuring the circuit is evaluated accurately. This test determines whether battery voltage is present at the relay circuit board, an essential condition for power flow to the PCM. If there is battery voltage, it confirms that the power supply circuit remains intact, leading to completion of this segment of diagnostics. Conversely, if voltage is absent, it suggests a potential open circuit in the +B IGP line, requiring immediate repairs along the power path from the fuse to the relay circuit board itself. In Step 9, reconnect terminals A and B using a jumper wire to establish a temporary circuit aimed at testing continuity. This would specifically be done between relay circuit board connector C, terminal number 5, and body ground. The aim is to verify that continuity is present, as this plays a crucial role in validating the functionality of the relay circuit board. If continuity exists, it suggests that no faults reside within the circuit, and you will want to check for any available service information or consider substituting the PCM to ascertain the core issue. However, if continuity is absent, it indicates there is an open circuit within the FI main Rayleigh CL wire linking the PCM to the relay circuit board, necessitating immediate repairs. The final troubleshooting step involves further diagnostics for the FI main RLY outline by disconnecting the relay circuit board connector C. Here, you would connect terminals A and B with a jumper wire to allow a test passage for continuity verification. Measuring continuity between the PCM connector A, terminal number 8, and body ground at this stage will confirm the integrity of the wire leading to the relay circuit board. If continuity is verified, you should refer to updated service information related to DTCs or symptoms being experienced. But if continuity fails to present itself, this indicates an open circuit scenario that must be remedied in the FI main RLY outline, ensuring flawless operation of the PCM and restoration of normal vehicle functionality. The final repair verification is critical in confirming that all previous steps have resolved the issue. Start by using the Honda Diagnostics System, HDS, to clear any diagnostic trouble codes, DTCs, including P0657, ensuring that the system is reset and ready for normal operation. Following the reset, it is imperative to conduct a test drive, allowing the vehicle to perform under various conditions, replicating typical usage after repairs have been made. During the test drive, observe for any abnormal behavior and ensure that the vehicle is operating smoothly without electrical issues. Upon returning, recheck for the presence of any fault codes. If DTC P0657 does not reappear, this serves as confirmation that the repairs have been successful, restoring proper functionality to the PCM. Preventive maintenance plays a vital role in ensuring long-term performance and reducing the likelihood of DTC P0657 reoccurrence. Regular inspections of electrical connections can preemptively identify loose terminals or corroded connectors that might lead to power supply interruptions. Additionally, checking and testing fuses periodically can help avoid unexpected blown fuses and disruptions to the electrical supply system critical for the vehicle's operations. It's also advisable to keep the relay circuit board clean from debris and moisture, as contaminants can impair electrical connectivity. These simple yet effective maintenance steps can significantly enhance vehicle reliability while ensuring that the PCM operates within its designated parameters. In conclusion, diagnosing DTC P0657 involves understanding the critical role of the Powertrain Control Module, PCM, and its dependence on a reliable power supply circuit. By systematically following the outlined troubleshooting steps, technicians can identify and address various potential issues, including relay failures, blown fuses, or wiring shorts that compromise functionality. Accurate diagnostics are essential as they encapsulate key aspects of electrical systems, emphasizing the significance of each component involved. Implementing preventive maintenance steps will not only enhance long-term reliability, but also foster proactive care of the electrical system. Ultimately, by paying close attention to the PCM and its power supply, we can ensure that the Honda Civic remains efficient, safe, and enjoyable to drive. Please like and subscribe to the channel. See you next time.